What's the fastest way to reproduce a scientific study? Here is a published scientific study. I want to modify the analysis to ask a new question or see what they did. How long is it going to take me to start doing that? Okay, ready? And we're done. What you're seeing is single-click extension of scientific studies. I'm now already in a coding environment and I have the data and the analysis code for this study already loaded. I can start modifying or adding to their analysis right now. I don't have to clone the GitHub repo. I don't have to download it and extract the zip on my computer and then figure out what environment it is and none of that. Can do that. Or I can just start hacking. Let's back up and I'll show you what I did. This is an article published by the American Geophysical Union on volcanoes. And there's this button right here that says Launch Jupyter. And if I click this Launch Jupyter Lab, it actually starts a Python server in the background and then opens Jupyter Lab, the coding environment, in my browser. It works on individual figures too. Here's a cool figure on the journal Elemental Microscopy that I want to copy and use on my own data. Just click the button and yay, I'm ready to copy the figure's code. Or I can change some variable and regenerate the figure right here. Being able to reproduce and extend a scientific study in one click like this has at least a few advantages. If you're a scientist, I'm sure you've had this experience of coming across a scientific article and you just have like one question. You're like, I just want this statistic that's not in the article. I just want to know it. I know I could calculate it from their data. I just want to run that really quick. You could do that. This article at AGU is actually more than an article. So from talking to Kayla, the lead author on this article, she was explaining to me that part of the reason they wanted to publish their science in this sort of very, very code-friendly format is that it's also a tool. It can help other people analyze volcanoes potentially on different planets and things like that. So their contribution to science here is also something they want a lot of other people to use. They want you to rerun this analysis. Same deal with elemental microscopy. My understanding is they're like the leaders in their field and they want to kind of show people how to do stuff. We're aiming to create scientific publications that work more like reproducible tools that everybody can use and less like just sort of static narratives. Okay, now I want to play you a couple clips from this really incredible gathering at the Howard Hughes Medical Institute on the future of scientific publishing.
But really, replication is the kind of peer review that we care about most, not the comments from a small number of people.
How do we create a much more data-rich, complete form of research communication that would truly enable a second researcher to build on that work almost immediately?
I'll put a link in the description so you can watch the whole thing if you want. But the two takeaways were replication as the highest form of peer review and being able to build on previous work immediately. That's what this technology really empowers. I think a lot of us involved in scientific publishing have seen these kind of executable research articles before, but the exciting part to me is they're starting to scale. It's not just a one-off CS journal doing this. This one-click open in Jupyter Lab feature is built on top of open source MystMarkdown and available in every article published through Curvenote journals. And we're starting to integrate it with other existing journals too. So stay tuned for more cool demos of the future of scientific publishing.